Hello developers, let's start developing. So, today we have task 11. We managed to fix task 7 so it runs, and now we have another task with a very fun input to parse. Basically, we are described some sort of a monkey-based state machine when we have a lot of monkeys with a lot of properties that are doing some complicated process. But details on that later. Now we basically need to get this into some data structure. To be honest, it might be faster and easier just to copy this over and paste it into something. But on the other hand, I really don't want to do that. I want to be able to parse this into an object. So this is a monkey. So the monkey has a few things. Let's define what those things are. So the monkey has an index. Let's call it, that's a number. We will try to have a list of monkeys where the real index of each monkey basically corresponds to the index of the monkey object. So, but still, we want to have those two data items separate so that we can check if we made a mistake or something like that. So, yeah, we can, to avoid going back and forth, I will just put this into some kind of a comment. Yeah, this is a monkey. So next we will have to have a list of items. These are starting items, but of course after a while we will have a list of full items. Yeah. I know that based on the task, those items will continually change, so I will just call them items because they're not gonna be that all the time. I will have an operation, and the operation is something that will calculate a new value based on an old value. It's basically a function, and such a function that takes a number, see operation worry level, expects an item. So this is the item. This number actually tells us how worried we are about that. So it takes a number that is the old worry and gives us another number which is the new value of the worry. Then we have a test, and that test takes a worry number and returns a boolean. Whether we need to, and that test will return a true or a false. If that test returns true, we are returning to the true monkey, which will be a number. And if that test returns false, we will be throwing it to the false monkey. So I will just call those two properties true and false. Maybe not the best names for properties, but they're the true monkey and the false monkey. Of course, I could just wrap all of this into one single thing, when instead of boolean, this will return a number, which is the index of the monkey that we should throw this to. But let's have it like this so that the parsing is cleaner. So now we need to parse this into a whole collection of these things. But the good thing is that the monkeys are given to us sequentially. So we have monkey 0, 1, 2, 3, and the real input that I have actually also does that. Monkey 0, 1, 2, 3, 4, 5, 6, 7. They are not given out of band. which is good because otherwise we would have even more problems parsing. So, first of all, we're going to need to read in the lines. And now we need to manage the lines somehow. Just a second, just to see if this actually works. Let's change the run task code so that we are constantly running the solution 11. Let's see what we will get here. We should just have a clean run through. And we can see that we did indeed run the code for day 11. We got it running. Now we need to do some actual parsing after we get the lines. And the lines are in batches of 6 or 7 or how many there are. 1, 2, 3, 6. So 6 lines are describing a single monkey. What I will do, it will basically do it destructively. Take the lines array, pop the first item, shift the first item, and try to get data from it. Not sure still whether I should be using regexes or not, but I might. So I will do something like this. Const result. This is an array of monkeys, and it's an empty array. While lines.length is bigger than 0, we need to parse a monkey. We're gonna take a monkey line. And once we have a monkey line, we're gonna need to get the monkey index. How to do that? Well, I already mentioned I love regexes, right? So we're gonna need to have this text. We have monkey space and then a few numbers 0. And we need to have this. And we are successfully extracting. So we're gonna do that. And then we have the index. I will separate everything into variables and then I will just construct the monkey. Yeah, this would have worked too. But we're gonna do monkey line dot match of 1. So we're taking the first captured group. We're gonna do a lot of assumptions. So we are gonna assume that the input is in the correct format. If the input is not in the correct format, we will get some nulls or some exceptions, but who knows? So next we have const item line. No starting items. Yes, so the regex for that will be space starting items. Otherwise we need to count all the spaces and things like that. And actually let's copy over everything to see if it matches on all of the monkeys because we have different monkeys. starting items, and then that, and then we have a number and a comma and a space, which can appear multiple times, and then we have multiple numbers. Yep, that is the definition, and I would not like to capture the first part. I would actually want to capture all of these, which I later will split on a comma space, which means that I don't really want to capture this group. Yeah, regexes can get quite complicated quite fast, even if you know exactly what you're doing, and this seems like what we actually want to do. Item lines is again lines.shift. So we're removing one line from the start of the array. We are removing them one by one. We're gonna, oops, not that. We're gonna item line dot match, not that, but our own regex. And clear use of multiple spaces. Well, actually, this is correct because multiple spaces can be weird, but I can say multiple spaces like this. Yes, this is better. And now, once we have the match, we just need to get the first matching, and that will be a string, and then we're gonna need to split it, and the split character is space, comma, space, and then we parse it. Sorry. So if this goes okay, this is the actual items, but I will stop here because this is a long and unclear line. So on the first line, we are just taking the first item, and that's of the match, and that's all there is. So now, and this is going to be a string. Now our items are actually item match, and we're going to split it. Okay. And we're going to just say return index and items. Yeah, you can see that this will cry because we don't have the rest of the... Oh, we don't need to return this, we need to push this to result. Create a new object, that's the monkey. And of course it says, well, it's nice because, but you need an operation, a test, and true and a false. Okay, let's make something that matches this. And this is always in the format. And to be honest, I checked in my real input. This covers, if we are able to map this, we will be able to map the regular input as well. We have old times 17, old plus 7, old times old plus 1, old times 3, old plus 4, old plus 4, old plus 6. So the only operators possible are plus and times. So we will have something like this. Let's remove this. So we will have multiple spaces, and then we will have operation and colon, and it's always new equals old space, and this is either that or that, and it's always a literal star or a literal plus. So we will have the operation, and then we have that, and then we have two options here. It will either be a positive number, which means that we have this format, or it will be the world all other. And then it just ends. Oh, ends. So here we will be extracting two values. Actually, we will be extracting the operation and the value. Again, line shift. We're gonna do a match, and the match, of course, this is not what we want. It's this, but I won't be doing this, and const. Now I'm missing a word because we're gonna need operation. I need something to call the plus on or the times. Let's just call that opkind. That's the operation match of the first one, and we can have op value, which will be the operation match of the second one. And op value is a string. It will either be the value of the old one, or it will be the value, it will be a numerical value. And now we get to create a function. Actually, I will make this into a helper function. Const make operation, which takes a, what does it take? It takes the kind, which will either be a plus or a times, and it will take the value, which will be either a number or the text OLD. And now we can see what we want to return. So, first of all, we will need something like this. So, if the value is old, now we don't know if this is a number. We will have to do this thing here. So the value will literally be a string. And now we're gonna use the fact that in JavaScript, if you try to parse the string old, you will get not a number. But weirdly, if you do this, is this not a number? It's false, because not a number is basically one of the very few things where it's not equal to itself. So we're gonna have to do something is none. and that is actually true. So that will be the constant that we're going to use, and that's going to be percent of the value, yeah, with 10. And this will either be a numeric value or not a number. If is none, if the constant is a none, then we will need to return a different function based on the kind. So if kind is plus, then we need to return a function that basically returns the old value twice. We don't really need an else. Otherwise, return worry times worry. Now, when we're here, right now, we are totally sure that constant is an actual number and that we wanted to do. So I will take this and do it like this. So make operation depends on the parameters, will return as a function that will take the old worry and return a new worry. So operation will be make operation of opcount and op value. And right now it's telling us, well, opcount is a kind of general string. How are you sure that it can only be one of those values? Well, I'm sure in more ways than one. First of all, I've looked in the input. Second of all, I've looked in the regex. So the only way for an operation to for the opcount to exist at all would be if it's a plus or a star. So next we have the test. And here we are doing the same thing because we have the test name that is test, and it's always the visible by and then some number. For completeness sake, let's check that here. All the monkeys have the same kind of test. We are always testing divisibility. So let's take the small monkey size, divisible by some number, and then it ends, and we do want to extract the number. So what we're gonna do now, oh, it's not offering a suggestion. It's gonna be called test line, and it's gonna be another shift, and we're gonna have test match. Good guess, but no cigar. Yeah, don't let GitHub Copilot guess regexes for you. Regexes are tricky. Thou shall never write a regex inside the code. Thou shall always paste the regex that you checked on some regex helper site. And here I can directly take the first one actually, and I can even do a parsing directly. So this line is in essence, except for the different regex, just the same like this. But right now we don't need to return the test match. We will need again to make a function. But this function is much simpler, so I can just say that const, it was called test, yes, test equals, yeah, this. Since the test match is already a number, if the test match is divisible by if the worry is divisible by the test match, that means the remainder will be 0 and this will return true. If the test is not divisible, the remainder will be anything, something that's not 0. We don't really care what it actually is. So, and now the only thing that we are left is if true throw to monkey number. Yeah, by now I think you get the gist. Const through line it got that it's something that works with monkeys, but not really. And this is actually true, the value true, but we cannot really use true as a variable, so I will call this true index. Let's change it here because it kind of bugged me. Yeah, this sounds better. And of course, then we have, it should be able to guess, yeah, false line, false index, if false throw to monkey. I think it's the correct one, but still, I want to see it. 3031. Okay. Let's paste it. And now we just need to put in, come on, true index and false index. And it says, I'm one happy monkey. Let's have part one and let's try to log the console. And since we have functions as part of an input, I don't think that we will be able to totally log everything that we want to. And it appears that we crashed it somewhere. Type error cannot read properties of null. Something is null. Let's stop this. And let's try to debug. And I think I know where the problem is. The problem is at our empty line because we used 6 lines, but it's not 6 lines, it's actually 7 lines. So once we're done with all the line shifting, we just need to pop one out. Lines dot shift. We don't really need the result. We can just throw it away. And the error we got was when we tried to basically do this on the empty line, and it says, sorry guy, but it seems like you don't have a monkey there. Let's see what happens this time, whether our monkeys are all in a line. So we attached the debugger and started to see what is happening. We have our first monkey line. So we have, these are the lines. 0, 1, 2, 3, everything is here. We have our monkey index, it should be 0. Yep. We have our item line, starting item 79.98. We have our items, which are 79 and 98. We have our operation, an op count, an op value. So the operation line says operation new is all times 19. Let's see what happens here. The constant should be 19. Yep. The kind is a star, so we are getting worry times 19. That is the correct operation that we need. And it's a function. The test match is 23, and it should be 23. So we have the true index, the false index, everything is great. The true index is 2, the false index is 3, 2 and 3, that part is correct. And we need to shift one more line. Let's see where the lines are starting. Yes, from monkey 1, we are returning result. And could it be that we made such a mistake? What a mistake to make. We are simply calculating the result and then throwing it away. Let's have it running here once more. We don't really need to debug at the moment. And here we have our monkeys. We have exactly 4 monkeys, 79.98. Seems that our monkeys are, aside from the functions that we cannot really see what is happening, everything seems to be in order. And well, one way to check that is to actually have them running. And let's see what the monkeys are supposed to be doing. So so far, we didn't even start solving our task, but we can now start that. So each monkey expects an item. But before it tests your worry level, your relief that the monkey's inspection didn't damage the item causes the worry level to be divided by 3 and rounded down to the nearest integer. So the process of inspecting something, so we can have a helper function const take monkey turn. And that we will get our monkey, and we will get the whole list of monkeys. Of course, we're gonna spell them like this. Then I saw her face, and I'm a believer. We need to take the monkey, and do we need anything else? Not really. We can have that monkey takes its turn. So what will the monkey do? So for each of the items, it will inspect it. And that means that it will calculate the new worry level. Actually, it doesn't work like this. Well, it does. We don't have a case in neither input when the monkey throws something to itself, which means that the monkey will take all of its items and basically throw them away. So at the end of its turn, that monkey has no items. Yep. So at the very end, we can always say monkey dot items is a new array. All the other items are gone. We threw them somewhere, and we will add them, those items, to the items of the other monkey. So we need to calculate the new worry. That is calculated by using the operation on the item. And then we have one thing that we need to see. After each monkey inspects an item, but before it tests, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down to the nearest integer. So we're gonna have to do math.floor of the operation divided by 3. No, we're not gonna take 2 away. We have the worry level. And now we can test the worry level. And if the worry level, if the tests return 3, we're not going to do the target monkey seeking because we made sure that the monkeys of true index is the correct one. And if it's not, then we give to the false index. And that's all there is. And our monkey doesn't really have any more items. One thing that we need to note is that the monkeys take things in turns, but not all at the same times. So first monkey 0 goes, monkey 1 goes, monkey 2 goes, monkey 3 goes. And we call that a cycle. But the cycle doesn't take place instantly. That means that if monkey 0 tosses an item to monkey 1, in the same cycle, that item will be expected again. And if that monkey tosses it to monkey 2, that means that the same item will get inspected 3 different times. So basically we could have just one item and have the monkeys passing it around round robin in a round robin fashion. So we will need to have some kind of a circular buffer to know which monkey goes next. And we can have some kind of pointer like this. So we're starting for the next monkey to be 0. And we have total of 0 cycles. On a single monkey turns, all the items one at a time are already listed. The process of each monkey taking a single turn is called a round. So it's not a cycle, it's a round. It was a cycle yesterday. When a monkey throws an item to another monkey, yes, we're doing that, we're pushing. That starts around when no items could end up inspecting and throwing many items by the time its turn comes around. If a monkey is holding no items at the start of its turn ends. That is taken care of here. If we have no items, this for just doesn't execute. So that's about it. Let's try a single round. We can say for input.length, this is a monkey. That's the input of index, and then we just need to take turns, take monkey turn, that monkey, and the input. So this will go through all of the monkeys, and then we can just console log the input. Note that this is a destructive thing. We would actually need to copy it over for part 2. But for now, let's just see what happens. So we are printing the monkeys after a single cycle. And the items that we have the following worry levels: 56. So the counts are kind of correct, but the numbers are totally off, which means that we messed up somewhere in the taking turns. We don't need to push the item, we need to push the worry level because that's the new value of the item. Let's see now. We are supposed to get 20, 23, 27, 26. And 220, 80, 25, 167, 207, 401, 1046. Yes, seems that we made a turn in quite a nice way. How do we copy over monkeys? If we just slice the array, that means that we will have the references to the exact same monkeys with the exact same items. So no, we're not gonna do a slice. I'm gonna do a map of monkey to a new object. Actually, one of those that will have all the same properties, but a copy of the items. We don't need a mapping, a slice would be enough. A slice only makes a shallow copy, and this way we will get the best of both worlds, since we will copy over everything that's not an array, and a simple copying over of this will work, of this will work, of this will work, of this will work, of this it will not work because it will copy the array reference. So once we change it on one place, it will automatically change on another, and that's exactly what we don't want to happen. And that's why we have this slice. So right now we have a copy of our monkeys, and let's see if that copy actually copied over just fine. When we're doing the second part, we'll see if our monkeys are fine, but actually we already have the second part running anyway. So what happens if we just say give me my monkeys? So the first part, we know that it already prints out the monkeys that are already changed. So we are expecting the second part to give us the original monkeys. And so it does. That's great. Which means we have a good monkey copy here. And now we need to see something like this. We need to run all of this for 20 full cycles. What is a cycle? After round 1, rounds. Few more rounds, round 7, round 20. So it thinks monkey 0 goes, It's round 1, monkey 2 1 goes, monkey 2 goes, monkey 3 goes, monkey 0 goes, and we are at round number 2. So each time monkey 0 goes, we increase the round. So we can say while round is less than or equal to 20, that's the magical number, that take monkey turn, the monkey that is indicated by the next monkey, or we can say, we can just call it current. The current monkey takes its monkey turn, and then we add one to the current, but wrap it around the length of the monkey. So this will go 0, 1, 2, 3, and then it will become 4, but 4 modulo the monkey length, which is 4, will give us 0. So, and we only need to increase the round if the current monkey is 0. And actually, we can do this here. But we don't want, no, this won't work. This might. So the 0th monkey takes its turn, and then we increase the round to 1. Now we want to start on round 1. And if the current mark, yes, this will work. We start on round 1, and the current becomes 1. So this will execute 90 times. It will not execute 20 times. And the 20th time it executes, that means the last monkey, the monkey number 3, or just had his turn, and current becomes 0. And we need to see the 2. Now we have the simulation going. So after, let's see if this is correct. Let's just again log monkeys. Now mapping, nothing, we just need to see some monkey business. The first, let's see if this is correct. 10, 12, 14, 26, 34, 245, 93, 53, 199, 115. The other monkeys are holding nothing. Knowing monkeys, they're holding something, but I marked this video as child friendly. So we need to count how many times a monkey inspected something. We don't have that number here. We have it, it happens here. But we can change so this returns a number. And so each time we inspect something, we just need to increase the result. Actually, this is kind of silly, because if it has 20 items, it will inspect 20 items. Monkey, not monkeys, dot items dot length. This is all that we need. We have to have it here because after that we're setting it to 0, and we have this. So inspected That's how many items we inspected is that much. And the result will be an array of the number of monkeys. And we are going to fill it with zeros. Before we increase the current, we just need to mark that specific monkey inspected that many items. So we're logging the monkeys. Let's log the result as well. Actually, let's not log the monkeys. There's been enough monkeys for now. I don't think that I ever said the word monkey so much. Yeah, I'm going cape. 101.95.7.105. 101.95.7.105. Yay! So we need to sort this by size. And this will sort it in a descending order, and then just 0 times result 1. Multiply the two biggest numbers. Let's see if this actually gives us. Of course it will. We'll just multiplying literally 101 and 105 that we already gotten, and this looks okay. Let's see if maybe we have some kind of a trick here, because oftentimes there is a trick inside the input of advent of code tasks when the test input, which is extremely similar to the real input, runs for something like a millisecond and the real input runs for something like 12 years. But we'll see about that. Let's restart it and see. It actually runs very fast. Of course, most of the time is spent on processing the input and we're getting some result. Here's hoping that it will be the right one, and it is. Let's see what the second part is. I'm kind of scared. You're worried that you might not even ever get your items back. So worried, in fact, that your relief has the monkey inspection then no longer causes your worry level to be divided by 3. Unfortunately, we need to keep your worry level manageable. You might be a very long time. 10,000 round. Well, that's fun. Yeah, this is gonna be fun. Now the problem is that we are not dividing by 3. And dividing by 3 actually on each turn kept the numbers relatively small. Let's just copy this over. I will rename this take monkey turn 1. And let's have it. So now for part 2, all we need to do is not have this and run for 10,000 rounds. Everything else is totally the same. But let's try this. We're copying the monkeys, but we're not gonna take turn 1, we're gonna take turn 2. And just console.log, not the result, but monkeys. So now the numbers are something along these lines. Yay! To the 155th power. We need to make sure how these things are changing. So, hmm, we are testing them in some way. I'm not sure if this will work. Yeah. The problem is that with such huge numbers, JavaScript has relatively limited precision. So basically nobody knows whether this number is divisible by 19 because the last 100 or so digits are basically random. So we have no idea whether it should go to monkey 2 or 3. The same goes for such big numbers, such big numbers. In this case, this actually makes sense. So we need to somehow lower the number constantly. And in order to do that, we need to do some kind of modulo arithmetic. And one thing that jumps at me is that all of our tests, basically, we need to do something that will make all of our tests basically constant. And notice that we don't really care about the worry levels. As long as we can replace a worry level with an equivalent worry level, this will work. And by equivalent, I mean one that will give us all the same stuff regarding all the monkeys. So the operations can be the same, but the tests are the problem. We need to make sure that this returns the same result anyway. So we are getting some random number. I have an idea. What if we find the common denominator between all of these numbers? These numbers are primes. So the common denominator between these numbers, the period, so to say. For example, if you have two prime numbers, 7 and 2, the period of and you have two monkeys, one is checking 7, one is checking 2. That means that the period when those monkeys work the same will always, or you don't have monkeys if you have two cogs. And cogs always tend to have co-prime number of teeth. So if you have a cog with 23 teeth, you will never pair it up with a cog with another cog that has 23, or with a cog that has 46. But you might pair it with a cog that has 41, because then the number of different combinations when they are touching is maximal, and it's actually the product of their of the numbers. Let's explain it once more. So we have, let's say, two smallish prime numbers, 3 and 5, and two smallish not so prime numbers, 3 and 6. So if we have one guy counting 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and another guy counting 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, and so on. 1, 2, 3, 1, 2. We are starting here. And in order to get a repetition of that, we need to go through all of the combination. So we have 15 different combinations of one guy counting to 3 and one guy counting to 5. And on the other hand, if these numbers are not coprime, 1, 2, 3, 4, 5, 6, 1, we got it here. We got it much earlier. So in order to have large periods with relatively few numbers, you need the primes. And in our case, the period of this, I'm not sure. This is a guess, so to say. The period of this can be something like 23 times 19 times 13 times 17. 96,557. Let's try to hard code this. Yeah. So if we hard code this number, not here, here. And this is the period, let's say. Which means that a worry level of 100,000 is basically the same with the worry level of 100,000 minus this. So we get some 100 level of worry level of this, and we will just take it modulo 96577, and we will get a worry level of 3000, which is more manageable. So each time we go over this number, we are doing a modulo. So instead of dividing by 3, let's just have it like this. We're taking it modulo period, and whatever the result is, the test will give us the exact same result according to each of the worry levels, and we don't need to know which monkey we're doing because this works for all the monkeys. So let's run it for 20 rounds. Did we have such a case? After round 20. Let's see what happens after round 20. We just need to save it. And if this is not correct, then this will be the first of the... Oh, we don't need this. We don't need the items. And we don't need the... This is wrong because it's on the wrong input as well. We just need the results. And then yeah, this can stay because that's the same thing either way. We need to see the results, and we are hoping that we'll get the results that we do want. This is running. This is the task. And we got 99, 97, 8, 103. I'm not totally mathematically sure that this is what's supposed to happen. There are some pluses that worry me. But on the other hand, yeah, this enables us to this will give, I'm totally sure that this will give the exact same result on a single run cycle, but I'm not mathematically convinced that it will give the same result on more than one cycle. Anyway, if the task says it's correct, then I'm gonna believe it. As I said, I'm definitely not sure that it will give the wrong answer. I am not sure that it will give the right one. So after 1,000 things, we have 5204, 4792, 199, 5192. Those seem correct. So let's ramp our monkey business to now 9,000, 10,000. No, that's too much zeros. Let's just do a 10,000 thingy. 51, 52, 166, correct. 47, 830, correct. 1938, correct. 52, 013, correct. And the result is 27133, 10158. I'm kinda happy about this, but no, 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 no. We have this problem. This is hard-coded here, and this won't be the case for the other input. So we're gonna need the period as a parameter. And how do we calculate the period? Monkeys.map monkeys.reduce actually. And let's just check that our numbers are actually primes. 11 prime, 3 prime, 5 prime, 7 prime, 19 prime, 2 definitely prime, 13, 17. Okay, so this has some nicer numbers than the test. So this will be 11 times 3 times 5 times 7 times 19 times 2 times 13 times 17. So it's that much million, but still it's passable. We still have the small input because I do want to check with that, because we will be reducing. We have our accumulator and our monkey. Whimper! We don't have the number that is the residue. We're added as a factor here. And we actually call it test match here. Let's just rename that, and then we need, in addition to the test, we need the factor as well. In that case, we don't really need the factor, but still, it looks better here. So for part 2, for each monkey, we're gonna take the accumulator and multiply it by the monkey factor. And of course, we're gonna start from 1. And that's our period. So we will just pass it along here. We're calculating it once based on all the monkeys and we're letting it run. Let's see if this works for our test case. Seems to. And the moment of truth. Restart, please. Well, we're getting some numbers, and it says that the result here is this number. It's quite a big one, and it's the right answer. We are one gold star closer to our starfruit collection, and to be honest, I'm very happy with myself for guessing the period thing. I'm still not convinced that is correct, but the proof is in the pudding. Don't forget to click like and subscribe, and if you like watching this thing, another video is most probably coming tomorrow.